Get the Point is a pre-algebra game that follows the standard of students understanding the relationship between proportional relationships, lines, and linear equations. Get the Point has some math terms to help increase understanding. Those are ordered pairs, a pair of numbers where order is important, often used to indicate a point on the coordinate grid, such as the x and y. Slope-intercept form, where a linear expression is written in this form, which is y equals mx plus b. The slope is the number m, and the b is the y-intercept, where the line crosses the y-axis. And integers, which is the positive numbers, negative numbers, and 0. The supplies that are provided in the pouch, along with your information sheet and guide, will be a Get the Point game grid, Get the Point score sheets, and 2 dice, a dry erase marker, and eraser. To play this game, students will start with the grid, and they will take turns rolling the dice to get 2 numbers. They can determine if they want those numbers to be positive numbers or negative numbers, and they will then plot them on the grid, and they can choose which one's the X number and which one's the Y number, and they'll plot that point. So in this case, I had 6, 8, so I went over 6 and up 8 and plotted my point. The next person will roll their dice and determine what, if they're positive or negative, if one's positive, one negative, however they want it to be, and plot that point. In this case, they did -2, 3. So they will continue doing it until they have 10 points on their grid. And I've made these points rather large so that they stand out. So once they have their points on the grid, they will their score sheet, and each student will have their own score sheet. And they are going to use their score sheet to solve for slope-intercept, which is y equals mx plus b. So they can choose any number between -9 and 9 to fill in the squares that make that slope-intercept equation. But for b, if you can see, you can't have more than -3. So although it says any number between -9 and 9, your y-intercept cannot be anything more than -3 because it's not on the board. So students will start by just selecting their own numbers and putting them into the squares on the game board. And once they do this the first time, they're just going to be guessing numbers and putting them in there. But as they get better at understanding how these numbers create the line, they are going to have better opportunities to make better guesses. And so they're going to fill all those numbers in. Now notice that I can select 0 as one of my numbers and put it in there, but I cannot use 0 more than 2 times. And in this case, I've used 0 in that equation, and I've used it down at this other equation, the last equation, and so I have to cross those zeros out, and I can't use any more of those zeros. From there, students are going to then start creating their lines, and they want their lines to go through one of the points on the grid, and when they do that, they'll gain points. So as we look at the numbers that are there, we're going to start plotting those points. So first off, we have a 3. In the first problem, we have a 3, which is where the number goes over the y-axis. So we're going to put an X there to show that we're on the y-axis at 3. And then the 4 is going to be our rise over run. So the 4 is going to go up 4, and then we're going to run 5. So we're going to go over 5, and we're going to place an X there. Once we have both those X's on, we will draw a line that goes through both of them and see if it hits any points. Although this one hits the corner of that red dot, it actually does not go through it, directly through the middle of it. It goes off to the side only because I made a very large dot. So it does not count. So then the next player will go, and let's say they use that next equation where you have 5, and I'm going to put my x on the 5 on the y-axis, and then I have a rise of 2, or actually -2, and the run of 3, which is going to take me over 3, and I'm going to place my x there, and then I'm going to draw my line that goes through both those points. And as you can see, I have still not hit anything. So I'm going to continue on. The next person goes. They have a 0 on as their y-axis, so I'm just going to be on the 0, and they are going to then rise the 4 and run the 3, which gets me to that point. I can draw an X through it. Now, once I have that X on there, I obviously have that point because I have an X on it, so I'm going to be able to score that as a point. But once I run my line through that point, I also run it through another point, and I get credit for that one. So that gives me 2 points. I've hit 2 dots on the board, and I can give myself those 2 points. So as I'm going through the game, I'm just trying to see how well I can hit the points on the board, which gives students a really good understanding of what slope, how to plot slope-intercept form. It also gets me thinking about the numbers that create it so that I can create the line that I need to hit through the points that I want. So it gets kids thinking about math in a number of different ways. So it's a really good game to have them playing. And eventually their board will look somewhat like this, where they have all the lines running through it and all the dots. So it gets a little crazy looking, but with the dry erase board, they can erase some of those X's if they don't go through the spots that they need. Some guided questions to help promote critical thinking. What strategies were used to calculate the desired lines? How did the game change when you rolled the 2 numbers in the equation? So you can change the game by the numbers that we had on the game board, in which we just selected our own numbers. As the students get good at this, they can roll dice to get what those numbers will be for any 2 of the boxes, and then the 3rd box they can come up with any number that they want. So it gets them once again thinking about the numbers and how to get it to get the outcome that they want. So this question addresses that. And how do you write 2y minus 6x equals -4, or I could say -6x, in slope-intercept form? So it's taking what they just learned and applying it to a math problem. And how could you create a horizontal line when playing the game? So some questions to help develop a deeper thought process into the game. Enjoy it.